we take the positive 60 with 0 here, and that's just the 60
So
degree.
wait, does it have to be plus minus 360 or just plus 360?
Oh, yeah, since k can be negative, we can just say plus any integer multiple of 360.
Okay.
And so that's going to be 60 degrees, or 300 degrees is also between 0 and 360, and that's negative 60 plus 360, right?
Wait,
So it's those three positions. Notice those are evenly spaced around the circle. So it's like 120 degrees between these, 120 degrees between those, 120 degrees between those. And in the next chapter, we're going to have de Moivre's theorem, where we'll be looking for the cube roots of -1 and in the complex plane.
Isn't that just -1?
And this is where we're going to find them, but we'll have to wait for that. Okay, so how are we doing? Should we enter these in and see that we get them right? 60, comma, what, 180? Comma 300? No, that's good. Keeping the
Could you enter the answers for my homework?
Can we either do a problem or
they're all pretty much the same as, I mean, I guess they're parametric, but
They don't like it when I enter it.
what number is this?
this is number 16, I think, is that right?
Oh,
Yeah, 16. So again, they want, do they want them between, in degrees?
yeah. It's in degrees.
Yeah, in degrees, huh? All right, so what do we do here? Let's write down the problem. Okay, so it's 7 cosine x minus 7 sine x cosine x. Equals 0? Yeah. Any ideas?
Can we square both sides?
You could square both sides. You might bring in extraneous solutions.
Can you divide by
Factor of cosine. He said factor cosine.
That's right. What else can we factor out?
Seven.
So, I mean, we've already got a greatest common
We
factor
can't do
here.
7 cosine.
The 7, right? So 7 cosine x times 1 minus sine x is an equivalent way of writing the left side in factored form. And since it's equal to 0, it's nice to have it factored, because then you can say, well, a product is 0 only if one of the factors is 0. So either cosine x is 0 or sine x is 1. Right? Where does that happen on the circle? Cosine x is 0 at pi over 2 and 3 pi over 2, also known as 90 degrees and 270 degrees.
Sine x is
Sine x is 1 also at 90 degrees, right?
yeah, 90 and 270. Wait, no, never mind. It's the same.
Yeah, so it's the same place. So basically there are two places where these are true, 90 degrees or 270. That's it.
But the sine x for the 270 is going to be negative
Yes,
1.
yeah.
Yeah, but you know, either one of these factors can be 0. So if this factor is 0, that's going to be true at 270, right?
Oh.
So 270, this factor is 0.
But the sine
That makes
x-
the product 0. So even though the sign is -1, and this will be a factor of 2, it's going to be multiplied by 0. Because 270, cosine of 270 is 0. So they don't, both factors don't have to be 0, either one or the other. It happens that at 90 degrees, you have 0 times 0. which is emphatically 0. Really 0.
So it doesn't have to
0
be-
squared.
Like,
What?
when you're talking about the sin x1, sin x1 doesn't have to be like, it doesn't have to apply to both of them?
Right, either one factor or the other
Okay.
could be 0.
So you're just listing out all the possible ones?
Right, just listing out all the possible ones. Okay, so this one is a little tougher, right, because it's got some decimal approximation. Use the inverse trig functions to find the smallest two positive solutions on this interval, and now we're talking about radians. Round to 4 decimal places.
Are you on 15?
This is 15, I think, or 14 maybe?
Can you skip? Because I don't know if it's never mind. Oh, you see, yeah.
14, yeah. I skipped 15, didn't I? All right. So, this is not a calculator exam, so I'll just leave it in exact form, and then we'll approximate it for my open math. But
Will this be,
this is fair game if you just write it in terms of the inverse sign, right? So, sine of 2x plus 5 is equal to 0, well, 1,802 10,000ths.
On 0 to 2, that's a period, I believe that's referencing to. What's the on 0 2 pi?
Yeah.
The period, correct?
Well, that's, they just say, find all solutions in that interval. On, in, I guess I would say in, but they said on. So, the first thing you want to do is use the inverse sign, right? So 2x plus 5. Now, there's two values, right? So this is the key thing, is you recognize that there's the actual inverse function gives you an acute angle, and then you get the supplement to that, which is an obtuse angle, right? So you get either the angle whose sine is 1,802 10,000ths, or pi minus that angle. Or any angle coterminal with those, but yeah, I guess we should. So 2k pi, right? Any angle coterminal with those, 2 pi k. All right, so we still have to solve for x, right? So 2x is going to be -5 plus the angle whose sine is 1,802 10,000ths plus, again, 2 pi k. And then -5 plus, I'm going to say any odd multiple, 2k plus 1 times pi. So when I add pi to 2 pi k, that's 2k plus 1 times pi. So this is an even multiple of pi. If I add pi to that, I get an odd multiple of pi. 2k plus 1, right? So then you got to divide by 2.
so
Wait, sorry, I was writing, so I missed
Yeah.
that. Why did you pull the k out of 2k pi?
I don't have to,
Because you wrote 2k pi times k.
but yeah, it's sort of nice to combine pi plus 2 pi k.
Oh, you took the pi up.
Yeah. So
what
that's
is,
2k plus 1 times pi. So if you add pi to an even multiple of pi,
Oh, is that a plus 1?
you get an odd multiple of pi.
So wouldn't the second one be -5 minus sine, inverse sine?
Yeah, thank you. Good call. I lost my negative.
Would not be negative, right?
Yeah. Now you have to divide by 2, right? So you get x is equal to -5 halves plus 1 half. The angle whose sine is 1,802 10,000ths. plus any multiple of pi now, right? And then the other one, it's gonna look like that, right? You're just this basic algebra, but, here you have to say, half of an odd multiple of pi, and that doesn't simplify in a nice way, does it? So, oh, that's a pi. This is a pi.
Oh, yeah, that's why I was confused.
You're wondering about that.
Yeah.
So, but, yeah, so this would be the way to write the set of all solutions. Now, what if we want the solutions between 0 and 2 pi? Well, we'd say k equals 0. Get k equals 0. Well, -5/2 plus 1/2. Actually, plus or minus, well, let's see. Is that gonna be, that's gonna be a negative value.